I'm ready. You ready, Bernd?
Have to.
Let's rumble! Maker Monday, everybody! Welcome to our new episode, and we have an old face with us. Well, it's not an old face. You were in the very first episode of Maker Monday episode that we did.
Yes.
Bernd, welcome back.
Hi.
What are we doing in the new Maker Monday?
We built some new devices today to measure some air pollution.
Because it's New Year's Eve. And what happens on New Year's Eve, Bernd?
I think a lot of fireworks.
A lot of fireworks.
A lot of air pollution.
A lot of air pollution.
Fine dust. And we want to measure it. So how much impact have the fireworks to the fine dust in the air?
And because we do this scientifically, we will have a control as well. So we want to measure the pollution in the city center, and we will also measure the air quality a little bit away from the city center, right?
Yes.
All right.
Yeah.
Very exciting. What parts do we need?
We made the decision to do this with LPWAN. Don't know if you heard about it.
I have. We've written about it on our blog, but explain what we mean by it.
LPWAN is a super interesting technology. So we can...
It stands for Low Power Wide Area Network.
Yes. We can transmit small messages, about 12 bytes per message, and up to 140 messages a day, so about every 10 minutes one message, on a battery without Wi-Fi and everything like this. So it's like a mobile phone, but we have a free range of up to 50 kilometers.
Okay.
So in cities maybe 1 or 2 or some 100 meters, but this all runs on a battery on a long time. So I think it's a nice technology to build this device and put it into the wood or somewhere in the car. So let's try it with LPWAN and Sigfox.
So Sigfox is the network that you can connect. It's a LPWAN network that we're going to be connecting to, right? Yeah. And we have a Sigfox sensor, I assume.
It's a Sigfox device. It's Arduino based, called MakerFox. It had a Sigfox module on top. Okay. Comes there, it's finished. Yeah. Okay. Don't need to do anything.
Where do you get something like that? You get straight from Sigfox?
You can order it in the Arduino shop. Okay. Or from Sigfox. So you have 1 year of Sigfox Connect services included in this. I think it's about $39. Okay. So it's an interesting device. All right. Let's get started. Yeah. We have some more parts to show.
Do we?
Yes. The sensor.
Let's not get started.
It's a sensor for the fine dust. You can...
Particulate matter.
Yes. You can put in here some small... what is this?
Pipe.
Pipe. Tube, pipe. I don't know.
Tube.
It gets the air from here. Here's a little fan in it. It will soak the air inside here and blow it out, and will measure the particles inside. Okay. So simple device. We will connect them. We have here.
That means this is going to measure the air quality, but we're sending the data to the Sigfox.
Yes, we measure it with here, then we connect them as a serial connection, and we send it out to Sigfox. So we need an antenna. So I think it's a small one for 30 kilometers of range. Okay. Nice. And we need 5 volt. So if we run on a battery which only has 3.6 or 4 volts, so we have a voltage regulator to push everything to 5 volts, so we can run this device. It's not super power efficient here, so I think we can run some days, maybe 1 or 2 weeks. I think not more, but we need it for one night.
We need it for one night, basically.
So I think this will work on battery. Good. So let's bring everything together.
Let's start. Let's start.
So, principle, it's super simple. Use a breadboard, the Sigfox device. So we've done a lot with these devices. So most of you will know we have a transfer line, receive line, power and ground. So let's connect everything together. This one is the ground pin. Take the red one for 5 volts. It's this one. Then we have transfer and the receive. So now we connect everything. The Sigfox here super labeled. So we need the voltage out here, 5 volts. We need the ground. We need the transfer and the receive. And like in other episodes, we have to switch them.
Okay.
So the transfer to the receive and receive to the transfer. So transfer was the red one. This one we connect to receive. The orange one is receive. We connect to transfer. Then the red one is power, so we need 5 volts. And the ground from the sensor. And yeah.
Okay.
We are finished.
Well, no. That's it for today's episode.
You need an antenna. So here we have a small antenna connector connected. And last of all, we have to connect the power here.
Yeah.
So yeah, it's not perfectly marked here. It's not the red one, it's the green one now. We put it on voltage in and the other one on ground. And that's everything.
That's everything, right?
Yes. So later we want to build this up in a small case with a housing with a 3D printer. And then we're finished.
Okay. So we put all of that into our little package that we're going to print and then put it on a balcony or something.
Yeah, maybe on a tree.
Or on a tree.
In the woods. We will find a good position for that.
Okay.
Good. So we have to write a little code for all this. I think we don't show today everything of the coding. I think we should talk about the technology and how this works together.
And we've already covered in a few previous episodes, we've already covered how to flash these devices, right?
Yes.
So the principle's the same. Go check out those episodes if you don't know. But you already know, don't you?
Okay, so let's switch to the laptop and take a look on the technology.
Yes.
Okay, Sean.
Yes.
Let's talk about what's happening if we put in a battery here.
Okay.
So the Arduino boots up like all the other microcontrollers we've used in the last episodes. We've done a lot with this. This sensor also gets power. The fan spins on. So
pulls in the air
in it, makes its measurements. So if this device has made the measurement, it collects all this data and builds up like a Sigfox message packet.
Okay.
Yeah. All the information is here. It's like a JSON string on the internet. Then it sends it through the antenna to the next Sigfox base station. I don't know. Like
however they do it.
Named the base station. They receive the data, and then we can configure what happens with this data.
All right.
So first of all, I want to take a short look into the code, not too much. So I want to show you, here we define this package. So we have some status, we have a module temperature, we have the measurement for 2.5 micron dust and for 10 micron dust. These are the two measurements we can get here.
Okay.
And yeah, that's the type Sigfox message. So we define the message, we fill up it with data, and here somewhere in the code we have a Sigfox send message.
Okay.
So we can search for it.
Maybe we don't.
So
here we do. Yeah.
Here's the part where we send the message, then the device goes to sleep. We've done this deep sleep stuff with the temperature.
Yeah.
Meter we have built. So it's the same technology here, but we don't have a temperature sensor here. We haven't found a sensor. So
okay.
It's nearly the same stuff here. So then we flash this on the device. So we said we don't do this today. We have done it so often. Everybody knows you have to push this single button here and then everything happens like magic.
Magic.
Yeah, we don't do this today. So let's talk about the Sigfox backend. So I'm already logged in here. Then if you only have one of these devices, you can click here on device, and after the first message you will find it here. We have a lot of devices, so you see more of them. I think this one is this here.
Right. And you get this access when you sign up for Sigfox. You get access to the back end.
Yes, you can register here. You can do it by yourself. Then every of these devices has an ID, so you can register them to your account and use it. It's straightforward. It's not really complicated. So if Sigfox gets a message from your device, it's will known by the device ID. So yeah, this one is called. They already have named used them before for another project.
Okay.
So then you can configure here callbacks. So this is the point where PRTG comes in. Okay. So today we don't use the Home Assistant because Home Assistant have some problems with historical data. I think we had an episode about this.
Yes, we did. We
did. But today we want historical data for some hours and days maybe. So we use PRTG. So I think Noor has done it in one of the last episodes.
He did. In fact, the last episode, you're 100% correct. Okay. We did. We took data from our temperature logger that we built and sent it to PRTG. So check that out as well to see how we did that.
Yeah, and this is nearly the same, but with other data. So we here at Sigfox we configure a callback. So we have a data uplink to an URL, and every time when data comes in, Sigfox will do what we configure here. So we have a payload configuration. This configuration matches the code here. So we have 4 values here. So the payload configuration is nearly the same here. You get the data type and a name for it.
Okay.
So this have to be matching. And these values now we can use here as variables. So we configure the target where to push the data. It's our Maker Monday PRTG instance to push data sensor like Noor used it in the last episode. So we see that later. So here the device ID is a variable which matches the device ID of your device, so it's unique. So it's always a great idea to use this to get a unique identification. So then we have a post method. We are posting JSON data here. And then we need a template which works with PRTG. So this is well documented in the knowledge base. We will provide some
PRTG knowledge base.
We also will provide
Paessler.com
the template. So here we send the state, and now here comes in the custom data we send from the device. So we use here from the payload the custom data state, the module temperature, and the fine dust values we collected with the sensor. So Sigfox will use all this data built together with this template and message. And then this message gets pushed out to this target here. So we already prepared that.
You got the
people have to trust us that this will work. So you can just copy.
Trust us, right?
You can just copy in that. We will provide some templates. So we create a second callback. So you can have a lot of callbacks for the same message. So you can push it to 1, 2, 3, 4, 5 destinations. And we configure a second one. That's really interesting.
Why are we doing the second one now?
Yeah, we configure a geolocation. So every time you send a message to a base station, Sigfox knows which base station you used. So you can calculate and circle where your device is. If your device is, you put it in the woods and it starts moving, you think somebody stole it. So you can walk and try to find him.
Okay.
Yeah. So it's absolutely the same. We configure a geolocation service. We send it also to our PRTG instance. Yeah. We use another name. We also use here the device ID with an additional geolocation, so to identify it's another sensor. So and then we build up here also like for the sensor data a template which PRTG can read.
Okay.
It's a JSON template. So if Sigfox receives a message, they will do both callbacks. So
we're basically going to get the particulate metadata plus geolocation data from the same device.
Yes, okay. And we can do this every 10 minutes. Let's take a look on our PRTG.
All right.
I've already configured a device, so you can see this. I think it runs for some hours in the morning. So here we get the first data.
All right.
But I think we should take a look how to do this. So we go to one device. I have two configured here. And then we can say here, add a sensor. We need an HTTP IoT push data advanced.
It's one of the sensors in PRTG.
Yes. You can give it a name. Just a name. So take whatever you want. You should find it later. So you see here we have port 5051. It's hard-coded in this instance. And here is an interesting part, the identification token.
Yeah.
So this token has to match with the URL you're using here.
Yeah, the target basically.
Yeah, so you need the device ID and PM for identification because it's particular matter. So, yeah. So I have labeled all these devices with their ID. So we have it here on the top. So if you use the variable, Sigfox will remove leading zeros. So you have to remove the leading zeros from the ID.
Good to know. I was actually going to say that.
It was a long time to find. It's a long time to find this. First time I've used these devices. So so we use this ID. Yeah. Sigfox will use it, and then we add PM for partial matter. You can also write here my fancy sensor, but then you have to do it
to match it up to the what you set up in the callback.
Yes, then you have to write in the callback my fancy sensor. Yeah. So it have to match, but you can use what you want. But the device ID is always a great idea. So yeah, that's it.
Create the sensor.
You save it, and then you're done.
You're done. You should be getting data.
Yes, if you plug in a battery.
We need power, don't we?
Good. I think I have a mission for you.
For me?
Yes.
Am I going to do stuff?
Yes.
What am I going to do? Put the batteries in.
Like in the cooking shows, I've prepared something.
Oh.
I've built a 3D printed case for this. The sensor in. We have the Sigfox here, some battery, antenna, the voltage regulator, everything on board.
Okay.
So we don't have Sigfox in the basement. So we should go for the door.
You mean I think what he's trying to tell me is he wants me to go outside.
Yes.
Are you aware that it's below freezing?
It's December in Germany.
All right, and so, I do not have my jacket with me. You're aware of these facts,
right? It's not my problem.
All right. So I liked it better when I didn't have missions.
Take this.
Yeah.
Take a battery.
Okay. Okay, so battery goes in there.
Yeah.
And then what do I need to do?
This way.
Yeah.
You do it this way.
Yeah. No, I think I can figure out which way it goes.
Good. And let's go.
What must I do? Just put the battery in, and that's it.
Like, you don't have to
push anything.
No, you don't need to push. It starts automatically.
Just put the battery in.
Put the battery in, and then wait.
Okay.
Yeah, wait about 15 minutes. So.
15 minutes.
Yes.
15 minutes?
No, 30 seconds. 30 seconds will be okay, but 50 minutes is a bit more fun. Without your jacket.
I'll get hypothermia and there will be no more Maker Monday host. Maybe a good thing. All right, let's go. Okay. All right. It's cold. It's cold. So we're outside. I've got the piece that Bernd printed and set up for us. All I have to do is put the battery in. So let me just get this bad boy in here. And now that it's in, I need to see. Green light should come on. Green light's not coming on. It's the middle of winter in Nuremberg. Oh, there we go, we got it in. Green light is on. Fan is running, so it's taking in some of the air. Middle of winter in Nuremberg, people. Things I do for the show. All right, so I think we got some data, but so we can hit. I wonder what this button is. I suppose Bernd wouldn't mind if I pressed it. It started the fan again, so I guess we're getting a second sample, or I've hit the self-destruct button. Who knows? All right, let's get back inside. Bernd.
You're back.
I'm back.
You believed in that 15 minutes or made a coffee break or...
Froze my butt off. Tell me something happened.
So, yes, it's green.
Green, so you got data.
So, let's take a look on our data. So here's just the name sensor we created some minutes ago.
Very clever.
So, and let's click in here and see what's happening here. So we got some data.
Yeah.
So we have a module temperature from 1638 degrees.
Sounds correct.
I don't know, you said it's cold outside.
Seems legit.
So yes, what's happening here? We have absolute crazy data which can't be okay. So 675 micrograms of fine dust. I think 40 is the limit in Germany. So no, that can't be correct. So what we have to do, we need some scaling factors. So on the temperature, for example, we have a temperature range from 60 degrees Celsius minus to 60 degrees positive.
Right.
So we need some scaling here. So from 60 to 60 we have a range from 120.
Okay.
And then we need some scalings to recalculate the values we calculated before with this device. So we make some number magic. And now we have to reverse this number magic. So I've made some templates here. And it's easier to just copy that here.
I guess it's like that to make the messages as small as possible that's being sent by the Sigfox device. Right?
So we will provide this in the GitHub repo. So you
check that out.
Just take this.
Links.
So we have a multiplication from 120 and a division from 32,768. So we apply that. And now we have a module temperature from 6 degrees. I think that's more realistic. So maybe we have 0 degree, but it don't cold up instantly after you leave the building. So maybe if it lays there for an hour or two, we have here something negative.
Right.
So the same we have to do with the fine dust sensor.
Yeah.
So we also have to do some scaling here. So the multiplication is 2000. I can't remember fine. The other one I will copy. So we just add it here. Scaling 2000 and the division factor.
And we should have a more reasonable.
So 21. We have 21. I think it's more realistic from business park or some.
Yeah, we're in quite a built-up area. A lot of businesses around here, so quite near the airport as well. So.
Yeah, I think it's absolutely realistic. So let's do this for the second channel. So now we have two correct scaled channels here in PRTG, so we can do everything we can do with fancy graphs and all this stuff. So because we are sending only every 15 minutes, this graph here will leaks in it. To correct this, a quick PRTG tip for users. So we match up the interval from 60 seconds to match the 15 minutes interval from this device. And
makes sense.
Then you won't get this holes in your graph. So this is really empty now because we have maybe you pushed the reset button. I have
what makes you think that? Guess it was a reset button then. I may have pushed the button.
So let's take a short look on this device. I've started yesterday in the evening. Only if you can see it. So
that's what the historical data looks like.
We get a nice graph here. It doesn't send because it was this device and we put it off to show this here.
Okay, cool, Bernd. So we're gonna finish building the second one by putting it into a case and everything.
Yes, like this one.
And tonight, which is New Year's Eve, we're gonna put one of these in the city center, and one of these out in the woods. So we can measure the difference of pollution and also how the pollution goes down once the fireworks have fired. Also check out our website. We have a lot of information about Sigfox. We have a tutorial video about Sigfox. There's some things on our knowledge base about it, so you can learn a little bit more about that technology as well. Watch our other Maker Monday episodes. We've got some interesting stuff coming up in 2019. Thank you for watching. Happy New Year, Bernd.
You too. Happy New Year.
Happy New Year to me. And Happy New Year to you. We'll see you in 2019 with the follow-up episode. We will have a look at the values that we get tonight. Party on.